All right, let's see how quickly we can knock out the multiple choice section for 2018's A-Level Paper 1 from AQA. So, what is the correct unit for the area under a force time graph? Well, force, the area would be force times time then. Force times time is impulse. Impulse is the same units as momentum. Kilogram meters per second. So it is B. A student carries out an experiment to determine the resistivity of a metal wire. She determines the resistance from the measurements as a wire and the corresponding unit. She measures the length of the wire with a ruler and the diameter of the wire using a micrometer. So, okay, so you're here, if everything is measuring a 1% difference, because your diameter has is squared to find area, it will offer the biggest uncertainty in your, like, so the largest I do want to say diameter because you're squaring it. So you're actually doubling your percentage uncertainty with your diameter because you're squaring it. Final answer. Because I'm super unsure of myself here. Yes, I am correct. So, fluoride ions are produced by the addition of a single electron. What is the magnitude of the specific charge of a fluoride ion? So, alright, so it's 9 plus 1. So, a fluoride ion has a excess charge of 1.6 times 10 to the minus. So, I'm going to use this one, 1.6 times 10 to the minus 19. Okay, divided by 19 divided by rest mass 1.67 EE minus 27. Ugh. Whatever, 1.6 EE. Right, that's why. Divided by 19 divided by 1.67 negative 27. Five times 10 to the 6. Okay, so next up. Two gamma photons are produced when a muon and an anti-muon annihilate each other. What's the minimum frequency of the gamma radiation that could be produced? Okay, what's the mass energy of a muon? $105.69. Mega electron volts, so times 1.6 times 10 to the minus 19. And then have to divide that energy by H. 6.63 times 10. Oh, why can I not? This is 30 minus 34. No. Minus 19. And then we divide it by 6.63. 2.5 times 10 to the 16. There we go, no problem. Just a straightforward application. So epsilon naught is a baryon, was to the quark up down strange. Okay, so a pion. So, pi plus ion is U is up, anti-down. Neutron is up, down, down. This here is up, down, strange. So strangeness must be conserved. Charge must be conserved. So I mean this has to be up, anti-strange. So yeah, I'm thinking up, anti-strange for that one. But I am not super confident in it. Well, I am now that the mark scheme says I'm right. Okay, so iodine nucleus decays into xenon 131. Beta minus particle and particle Y. Well, that is a anti-electron neutrino, so it is an antiparticle. So electron produced must be anti-electron neutrino produced. If it was an anti-electron, you'd have an electron neutrino be produced. Okay, so how many electrons? So I need to look at how many electron volts that is. So 2.0 times 10 to the 8 minus 18 divided by 1.6 times 10 to the minus 19. So 12.5. So 12.5. Okay, so So these two are out of reach. So I have 1, 2, 3, 3. 3 different ones that can possibly happen. Okay, so 14 photon wavelength, 290 nanometers, instant on a metal plate. Work function is 4.1 electron volts. What is the maximum kinetic energy of the emitted electrons? So again, this is... Okay, so E is... and then divide by 1.6. So H was 6.63 E to the minus 34 times 3 to the 8 divided by 290 to the negative 9, and then divide by 1.6 E minus 19. So 4.28 or 4.29 actually, minus the work function, 0.19. So in the diagram, P is the source of a wave, frequency 50 hertz. Well, the path difference is 8 meters. And the wavelength is 50 divided by, 30 divided by 50. Zero 0.6 meters, so 8 divided by 0.6. I'm embarrassed that I just did that. 13.3 lambdas is the path difference. So fringe spacing, so either to increase fringe spacing, we have to either increase lambda, increase the separation between the screen and the slit, or we have to decrease the slit separation. So that won't have an effect. That won't have an effect. That has the incorrect effect. Decrease the separation of the double slits. That's our only option. Diffraction grating has 500 lines per millimeter. When the monochromatic light is formed, the third order or spectral line is formed at an angle of 60 degrees from the normal. Okay, so d sine theta is n lambda. Just remember that this 500 lines per millimeter is 1 over d. So sine of 60 is equal to 3. I'm just going to rearrange it all right away. 3 is 500. Where have I bonkered this up? Oh, lines per millimeter. Times 10 to the 3. Okay. But either way, 577, so 580 nanometers. Okay, question 18. Okay, so it slows down to 3/5 of the original speed. So we've got c divided by our new speed, which is 5c. That cancels out, so it's 5/3, 1.33. 19 shows the path of light through the refractive index of 1.5. Okay, so it's parallel, so that's 45, that's 45. Okay, so I need to know that angle R. So theta R is equal to so this is an application of Snell's law. Right. So N1 okay, N1 is air, so it's 1 in this case. So sine of 45 is equal to 1.5 sine of theta 2. It's 28. So this angle here is Okay, 180 minus 45 minus 90 minus 28. Okay, so that makes that 17, which makes this 73. Okie dokie. So now I have to figure out what theta c is. Of 1 divided by 1.5? Yes, it would have to be. Okay. $41. Okay, so we are well past the critical angle here. So it has to be D. So you can see there's a lot with this question. And because there's so much to this question, you have to realize that, yes, there are some multiple choice questions that are going to take a long time. Okay? I mean, we could outright eliminate A, because it's definitely not going to bend towards the normal. But the other three, we still have to do the calculations. So any of the other ones that you can do really fast, you have to be able to know how to quickly do them. So this just really shows that these multiple choice, some of them take a long time. And actually, I'm going to double check that that's right, because if that's wrong, I'm going to be upset. That was question 19. Yes, it is D. Okay. So, 3 coplanar forces act on a point object. What combination of forces never produce a resultant of 0? Well, 3, 4, and 5 definitely can. I feel like it's got to be 888, but no, it's actually D here, because 3, 6, and 10, there's no way of adding 3 and 6 together in any way that ever ends up as 10. Whereas, like, you can put 2 and 10 at different angles, so that the horizontal and that, like, that they can cancel out, and you can make it cancel out in such a way, but you can never get 3 and 6 to ever add up to 10. So it's got to be D. Non-uniform sign, 8 meters long. Okay, well, taking my moments about P. I know that force Q times 0.8 is going to equal 18 times 0.65. Uh, 18 times 0.65 divided by 0.8. 14.625. And extension is force divided by K. Point 0.06. There we go. Immediately after takeoff from the surface of the Earth, a rocket has a mass of 12,000 kilograms and accelerates upwards vertically. Well, that's pretty easy. 1.4 times 12,000. 16.8. Okay, projectile is launched at the speed of 25 meters per second, angle 35. What is the time taken for the projectile to return to the ground? Okay, V vertical, V in the Y is equal to 25 sine 35. .3 meters per second upwards. 14.3 divided by 9.81, and then double that amount of time. .92 seconds. 2.9 seconds. You gotta double it because it reaches 0 at the peak, and then it'll accelerate for the exact same amount of time upwards as well. It's symmetrical. 24. Steel wire, W has a length L. Okay, so extension is proportional to length, and it's inversely proportional to the area. 1 over r squared. So what I have to do is, okay, so I need 1/4 of the extension. So 0.5 divided by 4, no. 1 divided by 16, no. 2 divided by 4 is a half. 4 divided by 16, D. Hmm. Right, so I need... Okay, so 0.64. I have to divide by 1.6 times 10 to the minus 19 times 60. But I then have to divide the number by 2 because the ions are doubly charged. So 1.2 times 10 to the 20. 1.2 times 10 to the 20. Mobile phone operates at a constant power of 200 milliwatts, 3.7 volt lithium ion, and a charge capacity of 940 C. What is the time taken for the battery to completely discharge? Okay. So 3.7 times 940 divided by 200 times 10 to the minus 3. And then divided by 3,600 seconds in an hour, 4.8 hours. Where have I gone wrong? Oh, 9,400. So 48 hours. Okay, so we've got twice the diameter, which means we've got 4 times the area. Which means that this is 1/4 the resistance of that. So 1 plus 1/4. That doesn't make sense. Oh, Y is an R. Okay, so Y is R. This is 4 times, so it's 5R. Yeah. Okay, 28. A voltmeter is used to measure the cone X, which rho gives a position and ideal resistance. So it's in parallel with X, and it has infinite resistance. Body performs simple harmonic motion. What is the phase difference between the variation of displacement with time and the variation of acceleration with time for the body? 0. Speed and displacement are pi out of phase, but acceleration, d, pi radians. Displacement with time versus acceleration with time. Oh yeah, because you have maximum acceleration at. That's interesting that they're considering that zero displacement. Okay. Mark scheme says D. I'm not 100% convinced. I'll have to take a look. 30. Maximum value of its kinetic energy. Object of a mass 15 kilograms. Performs simple harmonic motion. It oscillates with the amplitude of 55 millimeters and a frequency of 80 hertz. What is the maximum value of its kinetic energy? Okay. Okay, so Vmax is amplitude times omega. Omega is 2 pi f. Okay, so Vmax is 2 pi times 0.8. Okay, so 2 pi times 0.8 times 55 times 10 to the minus 3. Mm-hmm. 0.276. So I need to square that times 0.5 times a mass of 0.15. 5 millijoules. Okay. All right. Shows the gravitational potential energy of a simple pendulum with displacement S from the equilibrium position. I very much want to say it's D. Because it is. You just got to kind of think of it like this could just be height versus horizontal displacement. From equilibrium. Whew, that was a slog, but it is done. I hope that's helpful.